Good morning, everyone.
Morning.
Good morning.
So welcome to, I don't know what today's date is. I know it's Wednesday, the 29th, the EMEA Kubernetes demo. I do have something I want to showcase today. So let's do a minor show and tell. So I have been working on some tooling updates that target our HA proxy configurations. I had two goals. One of them was to enable us to be able to take down a backend that is targeting HA proxies that live in a specific zone. The reason for this would enable me to not completely disable Canary across all HA proxies. We still want Canary to be usable, therefore auto deploy still has a mechanism for which it has a backend to test against. If we completely disable Canary, we effectively block team delivery's auto deploy capabilities, and since we don't know the full scope of cluster outages, I don't want to take that type of negative impact to another team. So in order to be friendly to release managers, I've added the ability where we could disable Canary for a target zone. That way auto deploy still has some to test. And secondly, because we'll probably be doing this across all nearly 30 front-end HA proxies, I want to be able to do this slowly. That way, when we start disabling actual zones that are taking the brunt of customer traffic, so say cluster B, for example, becomes disabled, we want to move that traffic over slowly to the other two clusters. And the only way to really control that is to modify a single FE node one by one. So I simply added a small sleep. So just to showcase, I'm going to use staging. That way I'm not sitting here banging production. But if we do a get server state, let's say we want to look at the SSH backends specifically. Hypothetically, everything should be up. Let me see if there's any deployments going on. Okay, so there is a deploy going on. But it's past the Kubernetes part, so that's good. So in this case, and Jenny, just in case you're not familiar with this tool, all this is doing is reaching out to our Chef server, gathering a list of all FE nodes that we have. So in staging currently, we've got 2 FE nodes that are of type CI. We've got 3 FE nodes that are just our generic FE nodes that intake most of GitLab traffic. We do have a few others. There's one for pages, well, a set of them for pages and a set of them for registry. They do not run the SSH backend service. They don't intake that traffic, therefore they don't have an SSH backend. But we are inherently querying those backends. They're simply not showing up because there's no data to show. I'm targeting staging and I'm looking specifically for SSH. This is just a blanket regex, so it's looking for all SSH backends. So in this particular case, we can see that for all 3 FE nodes that we have in staging, the SSH backend service for all the clusters is up, as well as Canary. So my imagination is that what we would do is there's a convenient set server state. So my imagination is that what we'll do inside of our procedures for mucking around when it comes time to take down a cluster is that we want to disable our Canary backend explicitly. The reason for doing this is that we don't want to disable the zonal cluster and then Canary takes all of the traffic from that front end node. We would drown Canary if we were to do that. So let's say, for example, I'm operating on cluster B. I want to disable Canary for cluster B for the reason I just described. So we would effectively do, this is staging, so I'm not worried about ruining anything. We would set it to maintenance mode. And we'll do this across the board for all of our front ends, sure. And then to validate that this actually occurs is a little goofy. I'll showcase that in a second. But if we do another get server state, we're going to query all of our servers, but the UX of this particular tool is not great. And I'm not really sure how to make it any better because we're just using basic bash commands. Like we're grabbing the information for all the HA proxy nodes. We're doing a sort and a count. So we see that one FE node says that this canary backend is in maintenance, and we see that 2 of them are up. Based on what I specified here, where I specified zone B, I could take a gather that the HA proxy node located in zone B is the one that's in maintenance mode. But that's not explicit here, which is kind of disappointing. But in my procedures, I could always add another validation step just to make sure that people fully understand what the state actually is. We could also probably look at metrics to determine that, hey, FE, these sets of FE nodes all located in zone B are no longer taking traffic as well. So now that canary is disabled, the next thing I would probably do is go into here, and let's say we're again targeting cluster B, and we would just go in here and say, hey, you set you in maintenance. And because I know this is staging, but like, let's say we're doing this in production, for example, we'll want to like slowly roll across all nearly 30 FE nodes, but in staging, we're only going to hit one node. So in here, we'll target here, FE03 is the only node that's going to be touched. We'll say yes to this. And we even output a little message saying, hey, you desire the change to roll out slowly. So we modify our knife command to operate one node per time, or one node at a time. There's a concurrency flag on knife, the C flag or the concurrency flag. We simply default that to 1 in this particular case. And the actual knife command that sends to the HA proxy administrative socket, there's a sleep injected in front of that command. So for every HA proxy node, we sleep first, and then we set the actual flag. So if we do a get server state in here, what we're expecting to see is that canary is disabled across one backend, and cluster B is disabled on one backend, but cluster B will remain up for the rest of them. Same for canary. This is effectively what I'm imagining, and sure enough, that's exactly what we see here. This is effectively what I'm imagining what we'll do when it comes time to testing, bringing down a cluster of traffic.
Do you have any validation in place to avoid that people brings everything down at once?
Repeat that question, please.
So do we have any validation in place that these people using your tool to bring everything down at once? Something that is extremely disruptive.
Not really. This tool doesn't send any audit logs anywhere. It doesn't send a notification anywhere that it's being used. So not really. Normally this is used inside of change requests, but there's nothing preventing me from using here locally. I'm sitting here targeting staging with this, without any sort of issue at all. So no, there is not really that type of protection.
Okay. I mean, I'm just like someone not specifying the cluster B by mistake. What would happen?
Just bring down the wrong cluster.
Okay.
Which, would have its, a wide array of side effects.
Mm-hmm.
Like, what I would love to do is try to automate this. That way, instead of running this, not necessarily like locally, we would maybe like script this locally. There's a flag that I could set. This is taking forever. There's a flag that we could set on this tool that effectively is like a force flag where it doesn't ask me to hit enter to continue.
Mm-hmm.
And I could create another bash script that wraps around this tool that ensures that we could just copy and paste a single command that does precisely what we want. But that's just a wrapper script around this script. And at that point, we have to assume that we wrote the wrapper script correctly and that we're copying pasting maybe a shell one-liner correctly,
Mm-hmm.
anyways, I'll get these nodes back up and running the way I need to. Canary is the last one. But that's what I wanted to showcase. That's what I've been working on lately. So as far as the next steps go, the last thing that I wanted to make sure that we accomplish was making sure we don't block auto deploys. Right now, we've got a situation where if a cluster is down, our deployer will see that and will bail. And this is intentional because we don't want any backends to be down for the most part. So I need to make sure that we'll be okay, like setting some sort of flag that ensures that we could still proceed during a maintenance procedure such as that. We already have an environmental variable set today, or that I can set today that would do the same, but it's very global. It would bypass the check for all of our clusters, but I don't want that to occur. I want that to occur just for the target cluster that we're operating on. I think that would just be a more safe method of doing that. So that's the next steps. Any questions about this particular topic?
No, but seems cool that we can start to automate that and move to that direction. So sounds pretty interesting and promising.
Yeah. All right, so discussion items. I already talked about number 2. I went out of order, my apologies. Item number 1, get SSH. I wanted to bring up a chart, but I failed to do that ahead of time. So my apologies. Leading up to the GitLab SSHD enablement, we used to have an HPA that was leveraged heavily. But our EOCs started getting paged often enough to be concerned, but nothing was able to be found out of any research that was done. I'd have to go back and try to find that issue. Pod info. Whoops, wrong one. Shell pod info. So I'll share my screen again. We used to leverage the HPA of the GitLab SSH or GitLab shell daemon quite greatly. It would scale all the time. But because we were having issues and we couldn't find the root cause, we just told the HPA to don't do its job. So we effectively told the minimum replica set to be a value that was exceedingly high. What that led to was the inability for us to leverage the HPA. And now we're running a lot more pods than we used to run. No data?
This is after the rollout of GitLab SSHD that we removed the HPA.
This was just prior to it. Let's see if we can get this data quickly. No? All right. Oh, Grafana. Here we go. I'll switch to the Thanos. Let's see. Cluster B, GitLab shell, replica set. We'll just do a summation. Why? This one was called GitLab shell. I know it looks goofy that I'm looking for GitLab shell, but there it is right there. So why sum by replica set? Oop. Okay, so if I go back in time, we'll do weeks worth of data, and like we have to go all the way back to say, we'll go back to March. So we used to run roughly 40 pods. spiking upwards of 50 pods, right?
Mhm.
Well, sometime in, I think it was May, we decided because we couldn't figure out what was going on, we're just going to hard code this minimum replica value to 100. So now we just have 100 GitLab shell pods running across all of our zonal clusters. So instead of saying running 40 times 3, we're running 100 times 3, which is kind of unfortunate. I'm not a big fan of this. This is a lot of wasted resources.
What is
I would
what the
love to
current load?
see. Say again?
What is the current load on those?
It's not going to be any different than it was a couple of months ago,
Mhm.
but theoretically the load should be a lot lighter. Okay, GitLab Canary, GitLab shell cluster. Okay, this is supposed to be prefix GKE. And this is supposed to be Canary. I hate looking up metrics. It's the bane of my existence. When we performed a test, Michaela, you may remember this. When we performed a test where we sent all of one particular, I can't find it, screw it. When we did a test where we took all of the Canary traffic and ramped it up to like nearly 100,
Yes.
we were running like 8 pods in Canary and it withheld just fine. So I suspect we don't need to be running 100 pods, but we can be running closer to say 8 times 3 and still be completely safe. So I haven't opened an issue about this. It's just been something that's been on the back of my mind, but I'm curious as to whether or not we should fire up an issue. And maybe now that we've got GitLab SSHD enabled, this changes how GitLab shell used to work in the first place. It might be a good opportunity to try to see if we can't reduce the amount of pods we're running, which would thus reduce the amount of nodes we need. And as a side effect, because Prometheus just recently barfed in one of our zones, with less pods, there should be less metrics to scrape, which should ease the strain on Prometheus.
Mm-hmm. We're also reducing a lot the number of pod. Makes sense.
Yeah.
So from my point of view, we should go ahead and open an issue for that. I was just looking at, so there was I think an investigation going on from Igor and someone else from source code about doing some performance comparison that I don't think is completed.
Okay.
I would say maybe, do we want to wait the results for that? I guess not, but maybe it would be worth it to understand also which number are coming out of that investigation is about, if it's about to be finished.
And I guess, depending on timing, if we pull this before they're done with their testing, we could use whatever values we end up settling on as influence to whatever documents or whatever performance testing they're doing.
Yeah. Yeah.
All right, I'll get an issue fired up to address that. It's low priority. At this point, we're just wasting a lot of money, in my opinion. So
Yeah.
I think it's low priority, but this would be a good, it shouldn't be an issue that takes a lengthy amount of time. It'd be one of those quick wins, in my opinion. It would be time consuming because of the necessary need to perform the research and then make the changes slowly such that we don't induce an outage. We want to, kind of introduce changes slowly, maybe test them on one particular cluster before we roll it out to all of them, for example.
Yeah.
And then this is only impacting production. The change that we made that I described where we set the minimum replica count, we did not do that on staging. We only did this on production because only production was the environment that was yelling at our EOCs about stuff. So I'll fire up an issue. I guess I'll link this.
This is the issue on source code side,
Yes.
measure the performance benefit. That's what I was speaking about.
I'll link it all together. That way, whoever picks up tuning GitLab shell, we could kind of showcase some of that detail for them as well if they find it useful. Okay.
Thank you.
Any
Perfect.
questions about that otherwise? Okay, so we already talked about number 2. So Jenny, let's talk about what's going on with stateful sets, because this seems
Uh,
silly.
yeah. I mean, you two both have the context behind it, but yeah, let me just go over. So yeah, I was working on this issue to basically add basically a label to a stateful set, and it's not loading. Great. And I had this merge request before, just for the pre-cluster, just to test things out. You know, we're trying to add a stage main label. That's the only new thing. The change being, if there's a stage label, please add the stage label, which is main. And then once we ran that, so at first, the pipeline that starts running from this fails because the diff says, hey, this stateful set cannot take any more labels, basically. Other than these fields are forbidden. So basically we thought, okay, so we're going to delete the stateful set manually, merge the merge request, delete the stateful set, orphan the pods in that step, and then merge the merge request. And then the new stateful set theoretically should pick up the orphan pods, restart them with the new label. That was our theory going like from that, which is why I made this change request for that, which did not have the whole deleting pod step before. But then when I actually went and did that step, we came into an issue where it says the new STS couldn't pick up the new pods because the post operation against the pod could not be completed at the time. Please try again. Like it's a very ambiguous error that happens. So then we manually went in and deleted them one by one. Thankfully, in the pre-cluster, there were only 2. Now, what's even stranger is that, when I took down the first pod, it actually didn't say ready 1 out of 2 when the new pod came up by the new stateful set. It said 0 out of 2. So that made me worry again. But then we said, let's just go ahead and delete the second old pod. And then another one came up, and then that's when it turned 2 out of 2. Which just might be a visual glitch. I'm not sure why that stateful set behaved that way. But yeah, so basically that's the premise of what happened. I wanted to talk about that's the downside. And then because of that, if we're going to do this in a prod cluster, we're going to be doing this to 50 pods, manually bring them down one by one at a time, which takes around 5 minutes per pod, which made my change request have 260 minutes for the time to completion, which is less than ideal, right? So yeah, that was why I wanted this discussion. Now, overnight, Graham has suggested that, well, he noticed 2 things, right? He says that pre-cluster is the only one on k8s 1.22. And that might be the reason why the stateful set is acting that way. But then I thought, 1.22 is the latest one on the very stable release line, which kind of doesn't make sense. Like, why a stateful set would behave so weirdly on a very stable release. But I can do more research into that. And then also that Fluent Archiver can take downtime. So if it's going to take 260 minutes, then we should just delete the STS without orphaning the pods and just doing a full redeploy, taking downtime. So yeah, thoughts, opinions.
So just for clarification, it's not that the reason why we need to recreate this is not because the stateful set can't accept new labels. It's just that this particular configuration is simply not allowed. Like we can't make the change after the stateful set has already been created. So that's why we need to recreate it, because unlike deployments, these are the type of workloads where this type of change is simply forbidden by the Kubernetes runtime for X reason. I'm sure there's a design decision behind it, whatever. I think Grain pointing out that the pre-cluster is slightly newer is just pointing out the fact that maybe there's a change brought into 122 that may differ with the way stateful sets behave versus 121, which is what we run everywhere else. So something I'm curious about, and I'll leave this up to you as to whether or not you want to test it this way, if you want to go with your new testing. Well, I guess before I ask, have you tested this at all on the ops cluster at all?
No, I thought we'd have this discussion before I go
Okay.
ahead and change other ones.
So one thing I'm kind of curious is about, because I know stateful sets like to work in a backwards format. You know, it's always building the first pod, and if there's a change that needs to be introduced, it's going to make that change to the latest pod. So in like pre, for example, was running 2 pods. So you have the pod 0 and pod 1. I'm actually curious as to whether or not if you deleted pod 1 first versus pod 0, if that would have made any difference. I suspect not, because the error we got is very generic and doesn't lead us towards any sort of troubleshooting direction. So I suspect there was probably a conflict with the name, and Kubernetes didn't know what to do because a pod was already named that. So I suspect that deleting the pods overall is going to be what's required. But it's just a curiosity that's, itching my brain, So I don't know whether or not you want to test that theory out on ops. I'll leave that to you. Otherwise, I think FluentD archiver, FluentD uses that positional file so it knows where it stopped when it was last running. So like Graham said, we can take downtime. It's just a matter of making sure we limit that downtime as much as possible so we don't end up making FluentD suffer too much by taking too many resources as it catches up. We also don't want to drown wherever those logs go to, which I think, if I recall, go to GCS. So that's probably not an issue for us. So I see 2 options. If you want to try to figure out if, stateful sets behave differently on version 121, we could repeat the exact same experiment you did already, which I suspect is not going to change anything. Or we could go about testing your new procedure, which is just simply deleting all of them and, hitting that deploy button.
How about this? Yeah, so in the ops cluster, so we have ops, staging, and prod left. And obviously
Yep.
don't want to test on prod, but on the ops one, how about we test out basically what you suggested, delete the last one,
Yep.
delete the last pod, delete, or rather, I'll delete, like orphan delete the stateful set, I'll delete the
Yep.
last pod, and then I will deploy the merge request.
And you'll know very quickly whether that's going to work, because as soon as it tries to create that second pod, you'll probably see that goofy error that's not helpful. So you'll know it's a failed experiment at that point. So then you know what the
Exactly.
recovery method is. So that'll be a short experiment too.
Yeah, and then if that experiment fails, I'm just going to delete all the pods, delete the new stateful set, and then I can redeploy that pipeline, right? Like run the deploy pipeline
Retrying it.
again.
Yeah.
Even though it succeeded before.
Yes.
Okay. Yeah, then I think I'll do that. And then depending on what comes out of that, go forward with that on staging. I'm guessing it's going to be the whole delete the whole thing and then redeploy.
I suspect the same.
But if we don't have to do that, it'll be ideal. Just because 50 pods, it's a lot.
Yeah.
On prod,
and it's strange to me that they take so long to die. So I wonder why that is, but I also don't think it's a huge deal either.
It might be because it's keeping track of where it leaves off.
Yeah, but that's quick to write, just, stop reading logs, write the position, quit.
Yes.
You don't need 5 minutes to do that.
I know. I don't know why it takes around 5 minutes. but
wow.
it is what it is. So yeah,
I
I'll go
do
forward with that.
I do suggest you just validating that between, the last time we looked at cluster versions, that ops wasn't updated to 122.
Yes. Yeah. Agreed. If it was, I'll do it on the staging or something.
I just can't remember what the ops upgrade schedule is compared to everything else. So that's why I suggest doing that before you do the test.
Makes sense. All right. Yeah.
Cool.
All right. Thanks for the discussion.
Alrighty, Michaela,
Anything
do you
else?
got anything?
Nothing new.
I don't have anything else either. So good. Nice short meeting, and we got a demo in there, so I'm pretty excited.
Yes.
Nice.
Cool.
Thank
Well, you
you.
all have a lovely day.
Thank
You
you.
too.
Bye,
Bye
everyone.
bye.